you have a rather radical, or maybe not radical to you, idea of what radiation is, because most of us, when we hear the word radiation, it's a negative thing. And from what I understand, you feel that it's the dosage that's the issue, not the actual radiation.
Well, I mean, of course, the effects of high levels of radiation are much more severe than the effects of low-level radiation. I think that's obvious enough, isn't it?
Well, but that the effects of low-level radiation might actually be beneficial.
That's the question. I mean, the thing that's really known, the scientific evidence on radiation causing cancer, which is the important issue here, all comes from high doses of radiation, like among the Japanese A-bomb survivors, for example, or people exposed in in medical situations or in occupational exposures and things like that, where there have been excess cancers experienced. But these were all with rather high doses of radiation. And the question that I've been, well, the whole scientific community has been interested in is, what about the effects of low levels of radiation? Now, the paradigm that's been used for the last 60 years or so is to say that the cancer risk from radiation is just proportional to the dose. So, for example, if we know from experience what the cancer risk is from 100 units of radiation, then it's sort of assumed that the cancer risk from 1 unit of radiation is 1/100th as much, and the cancer risk from 1,000th of that is 1,000th as much, and so on, all the way down to 0. And that's the origin of the idea that no level of radiation is perfectly safe. So people start worrying about low-level radiation, which, of course, life is full of.
I mean, it seems to me you can't avoid but being irradiated. I mean, just the sun coming through the window is going to have a certain amount of radiation.
Well, there's all sorts of radiation that we experience. There's radiation, cosmic rays coming from outer space. There are radioactive materials in our bodies, which give us radiation exposure.
What radiation components do we have in our bodies?
Well, for example, potassium, which is in our bodies and is necessary to life, is radioactive and has not very strongly radioactive, but it's enough to give a fair amount of radiation. Then there's radioactivity in the ground, uranium, thorium, radium, things like that in the ground, and several other things.
But that's something that we sort of see as in the ground and to be avoided, versus potassium, which people buy all the time over the counter.
Well, the radiation in the ground doesn't stay in the ground. It comes shooting up at you and it gets to you. Then, of course, we derive our building materials, bricks and stones and so forth, from the ground, and they all have radioactivity in them. And
I mean, if you took a Geiger counter over a brick, would you get any kind of a click?
Yes, of course.
That's amazing.
Or on the ground, or on your body.
So,
or just hold it up in the air, coming down from outer space.
So I'm fascinated. Okay, so you've studied, how many studies have you done on this topic?
Well, the one that's gotten the most attention is my work on radon. Now, radon is a radioactive gas, naturally radioactive gas, which comes out of the ground, gets in people's houses, and all houses have a certain amount of radon inside the house. And people are inhaling that radon, and that gives them a radiation dose. And it turns out that's the largest radiation dose that people get in general. And the effect is that type of radiation should cause lung cancer. You're inhaling it into your lungs are exposed, so that should cause lung cancer. And according to this paradigm I mentioned before, The amount of radon that we experience in that way should cause something like 15,000 lung cancer deaths every year in the United States. So it's according to this linear no threshold paradigm, it's a very important problem. And therefore people test to see what the radon level in their home is, for example.
But what did your study find?
Well, to get into the study, I was involved in this, people wanting radon measurements in their homes, so I got into a big program of testing radon levels in homes. In fact, I ended up measuring radon levels in 350,000 homes throughout the United States. So that gave us a lot of data, and we accompanied all our measurements with a questionnaire. So we were able to put the answers to these questionnaires together with the result of the radon measurement. And that's the basis of this study we did. And what we found was you would expect that houses with higher radon would cause more lung cancer. But the way we compiled our data is by counties. So we derived the average radon level in 1,700 counties throughout the United States. That's more than half of all the counties in the United States and includes 90% of the U.S. population. So we have a tremendous amount of data then on the average radon level in each county in the United States. Well, then what we did was looked at the relationship between the average radon level in counties and the lung cancer rates in those counties. Of course, the government compiles statistics on radon levels, and on lung cancer deaths.
Right.
And what we found was that, what we were expecting was we would find that counties with higher radon would have higher lung cancer rates at a certain predicted rate. We found just the opposite, that counties with the higher radon had lower lung cancer rates, just the opposite of what this theory was predicting. Now, of course, that's just the beginning. We found that out around 1989 or so. Spent the next several years trying to understand how that could possibly be, or what we could have done that would give you the wrong result there. Of course, the first thing you think about is smoking. Maybe counties with high radon have less smoking than counties with low radon. So the first thing is to get a good correction for the amount of smoking in the counties. And this we did by several different methods. And when that was all done, the results remained the same. It had very little effect on the results. After you correct for smoking prevalence, counties with a high radon level had considerably lower lung cancer rates than counties with low radon levels. Well, then we start looking for other possible explanations. That's what's called confounding factors. For example, maybe it depends on, well, the first thing we thought about was socioeconomic factors. For example, maybe counties where people are poor would happen to have higher lung cancer rates because they're poor, and maybe counties with low radon levels have people are poorer in counties with low radon levels. Anyhow, the whole point is,
Right.
we thought that there would be a correlation between the economic status of people and the radon levels.
People that could get rid of radon were of a higher economic,
Or had better houses,
right,
more tightly
security.
sealed houses, or better ventilated houses. There's all sorts of reasons you might think
Not at all.
that would do it. Well, then, so we studied this very intensively. Well, first thing you can do is study it as a function of the average age of people in the county. And so for example, to show how we did this, we looked at all the counties where the average age is oldest, with the oldest average age, all the same, pretty much the same age, but old. And just looking at those counties, we still get this effect. Counties with high radon have low lung cancer rates and vice versa. And then you do it with all the counties with very young average age and get the same result. And then every intermediate average age, you get the same result. And then, you might think that it's some particular age group. Maybe it's counties with people that have a lot of people aged 60 to 75 for some reason. That would correlate with radon levels and with lung cancer. But we found if you look at all the counties with a same number, with the largest percentage of people aged 60 to 75, just for those counties you get the same result. High radon meant low lung cancer rates. Or if you looked at all the counties with the lowest percentage of people age 60 to 75, again the same result. We did this with altogether we studied over 500 potential socioeconomic factors. There's average income, ages, all sorts of socioeconomic factors anyhow. And in every one we tried doing it that way. You looked at all the counties with the highest values, you get that result. All the counties with the lowest values, you get that result. All the counties with average values, you get that result. And then intermediate values and so on. Then we got into other areas. What about environmental factors like urban versus suburban or rural? And there are effects. I mean, in general, urban houses have lower radon than rural houses. That's a true effect. But if you look at only counties which are only the most urban counties, you get this effect. High radon goes with low lung cancer, low radon goes with high lung cancer. If you look at only the rural counties, you get the same result. And then counties which are 50% rural, you get that result and so forth. And we sliced up the data in every way we knew how. And as I say, we had data on over 500 socioeconomic variables, on things like altitude, on temperature. If you look at only the warmest counties, you get that result. High radon goes with low lung cancer, low radon goes with high lung cancer. If you look at only the coldest counties in the country, you get the same result. Or all counties with intermediate temperature. And then did it with rainfall. If you look at only the driest counties, you get that result. Look at only the wettest counties, you get that result. And then any amount of precipitation in between the highest and the lowest. Any way you slice up the data, you get that same result. Then there's altitude. And there's geography. You can think of ways that geography would make a difference. So the Bureau of Census divides the countries up into regions and districts. For each region individually, you get that result. For each district individually, you get that result. Then you go to individual states. For each state, you get that result. Look at all the counties in a given state. We only consider states that have at least 20 counties in our data. But there were about 35 states, or then others you could group together adjacent states. And in each case, the counties with a high radon had low lung cancer, counties with low radon had high lung cancer. And then we went beyond that. We said, well, maybe there's something we're not thinking of here. And I developed ways of, demonstrating to my satisfaction at least that there couldn't be any unrecognized confounding factor that would explain our results away. So I'm convinced then that it's really true that counties with a high radon, no matter, that it's not confounding factors, that it's the radon itself that causes counties with high radon to have low lung cancer and counties with high radon to have low lung cancer.
So I'm curious, why is the government so obsessed with getting everybody so worked up about having high levels of radon in their basement?
Well, there's...
I mean, didn't anyone look at your studies?
Oh, there's been plenty of people looking at them, but they just... there is another approach to looking at the problem. That is, they get a lot of people who have had lung cancer and a lot of people, similar people who didn't have lung cancer, and measure the radon levels in their homes. And what they seem to find is that the homes of people that had lung cancer had higher radon levels than homes of people that didn't have lung cancer. Now, there's a lot I can find to criticize in those studies. For one thing, they don't show anything very definite. I mean, they're very poor statistics, and they're consistent with no effect at all in all cases. But they claim there's a tendency, as I said, for people who have had lung cancer to have higher radon levels in their homes than people who didn't have lung cancer. Assuming they chose the two groups in similar ways, they do try to choose a group, at least they match them by age, and I don't think they do much of a job of matching by socioeconomic status. They don't consider any, or very little consideration to confounding factors like socioeconomic factors and ethnicity, things of that sort.
Or other factors like how many people smoked and...
Well, no, that they do. I mean, anytime you study lung cancer, you have to consider smoking. So, they take, in the two groups, they have the same number of smokers and the same number of non-smokers.
I see.
So they're not that bad off.
I was just curious, because it just seems to me, why wouldn't they accept your findings as having any weight?
Well, I don't know that they don't. I mean, the health effects of radiation this is only one little aspect of the issue of the health effects of radiation.
But it seems like they're perfectly happy to radiate people to quote-unquote cure cancer, and yet that to me is a highly toxic cure.
Well, but if it cures the cancer, then it's worth doing, of course.
Well, the cancer was cured, but the patient died.
No, the patient wouldn't die till 20 years later.
I'm kidding.
I mean, ordinarily, if you cure cancer, then that's a very successful treatment. Well, I don't understand why people don't accept the results of my study that as a clear indication. They have this other data, which they always point to about what I was talking about, studying individuals who had lung cancer and didn't have lung cancer. I mean, comparing the radon levels in their homes. As I said, they're always fairly marginal statistically, consistent with no effect at all, but the claim is that there is a tendency to get an increase with increasing radon when you do it that way. But then the issue of the health effect, the cancer risk from low-level radiation is very much broader than that. The first thing they say is when the way radiation initiates a cancer is it hits a DNA molecule and does damage to it, and that starts a cancer. Well, then obviously, if you have more radiation, you have more cancer-initiating events. And so that if you assume that that's the whole story, then it's true that everything should be proportional. The cancer risk should be just proportional to the amount of radiation received. Now, there's a lot of arguments against that. I have papers on that. For example, it turns out that high-level radiations, like the radiation where we know it causes cancer, causes different types of genetic damage than low-level radiation. Certain genes are turned on and turned off by radiation, and the ones that are turned on and turned off by high levels of radiation are not the same ones that are turned on and turned off by low-level radiation. But that argument is very clear that ought to cause one to reject this linear theory. But
and the linear theory being that I'm just trying to.
The linear is that 1 unit of radiation is 1/100th as risky as 100 units of radiation.
Got you.
And so on.
Got you.
Going up and going down from there.
Right.
So that would be a good reason. Another point is that it's been found that low-level radiation stimulates the immune system. And the immune system is a thing that prevents a cancer. Well, once you've initiated a cancer, you've done damage to a cell, then it's a long way from that point till you have a tumor. I mean, a lot of things have to happen. A tumor has trillions of, or billion, probably trillions of cells, and it's just one cell which got damaged. So a lot has to go on between those two things, and the immune system is one of the things that protects us against that.
Well, on the autophage, the fact that the body sort of eats itself, when it gets damaged, it breaks those bits down and reuses them. I mean, I was just reading about that the other day, is that one aspect of aging, for example, is the fact that our ability to break our body down and regenerate starts to fall apart. And it would seem to me when cells get damaged, then they become food for the rest of the other cells. But that's another.
I guess I don't know about
well,
that.
anyway, that's just another theory that I was reading.
Yeah, I've heard things like that, but I don't see the connection here especially. But anyhow, the immune system is sort of the primary protection against a damaged cell ending up as a fatal tumor. And it's been shown in many ways, in many experiments, that low levels of radiation stimulate the immune system, whereas high levels of radiation depress the immune system. So that alone should negate this simple theory. Another point is that it's been shown that low-level radiation stimulates production of repair enzymes. The point is when a DNA molecule is damaged, there are repair enzymes which repair that damage. There are trillions of damage events every day in a person's cells, and essentially all of this gets repaired by these repair enzymes. Well, it turns out that low-level radiation stimulates production of repair enzymes. So, for example, there are certain types of mice which are inevitably going to die of cancer. I mean, there's certain breeds, they bred breeds of mice that they all die of cancer. But if you give them this low-level radiation, a lot of them don't die of cancer as a result because it stimulates the production of repair enzymes. There's several other things that way. Well, the vast majority of cancers are caused by corrosive chemicals. That is, DNA damage can be is ordinarily caused by corrosive chemicals, which now it turns out that low-level radiation promotes scavenging of these corrosive chemicals. That is, it scavenges corrosive chemicals out of the cell, and which means that there's less naturally occurring cancer.
So you're saying that low-level radiation gets corrosive chemicals out of your system?
Right, yeah.
Like chelation? Like, does it attach to it and pull it out? I mean, I don't quite understand, but...
Well, the experiments are, they measure the amount of these corrosive chemicals and then see what the effect of low-level radiation on them is. And it turns out that it reduces the amount of these corrosive chemicals. Another thing is there's a process called apoptosis where when a cell is damaged, it commits suicide, basically. This is one of the things that saves cancers from... As I say, there are trillions of cancer-initiating events take place, and almost all of them, damn well better, be that essentially all of them are repaired. And another big factor is a lot of them commit suicide because there's this process by which they commit suicide called apoptosis. And turns out low-level radiation stimulates this apoptosis. So there are many mechanisms available for why low-level radiation should be protective against cancer. One other one is that once you have DNA damage, hopefully it gets repaired before the cell divides. The time between when the damage is done until the cell divides is time when you could get it repaired. Once the cells divides, then it's not that easy to repair because you have 2 of them and then 4 of them and so on.
And what kind of window we're talking about? How long is that?
It's might be a week or
A week.
A month, maybe. Could of course be a minute. I mean,
Right.
any time between up to
But
many days, up to